Cool. Cool. 679, 24 game. Hard. You have 4 cards, each containing a number from 1 to 9. You need to judge whether they could operate through multiplication, division, addition, subtraction, parentheses to get the value of 24. Okay. I mean, there are a couple of examples, and the division represents real division, not integer division. That's a little annoying, but could be done. You cannot concat numbers, okay? And every operation is done between 2 numbers. In particular, we cannot use subtraction as you know. Okay, sure. Right. Oh yeah, not the first one anyway. Okay. Okay. How to think about this? I think my first thought is that I mean, there's only 4 numbers. You could definitely brute force it, and I think the naive thought that you might gravitate to is like, oh, it's just 4 factorial, right? And that should be, that good enough. And you're right. And actually, 4 factorial is what, 24. I don't know if that's intentional. Anyway, but that's also not quite the right answer or the right analysis, because even in the first input, they tell you that, like, look, like 4 factorials, if you have like them in the right order, but you have to add in parens, and that that kind of that means that there's a there combinatorically there are way more possibilities as well. But that said, it's not too difficult. I think another the way and to kind of solve this is instead of doing the 4 factorial way, which is just you do one operation and then you go to the next one and so forth. But but the way to do it is just it's still iterations. Every step of the way, you just take you take all possibility of 2 numbers, and then you do all operations on them, and then you put that in the next thing. Don't remember how to analyze it, but it should still run in time. Maybe we have to do some memorization if necessary, but hopefully it should still. I mean, we can think about it a little bit more, because you start with. Let me add a comment. Start with 4 elements, and then after one iteration, so you have, was it 12 possibilities? Yeah, because you take 2 numbers, which is 4 times 3, and then you do operation numbers. So there's like a lot of operations. But okay, I mean, I think that's just, I don't know, just YOLO it and then see. I think we can analyze it if this is actually right. I think the other thing to be careful about is kind of the division operator represents the real division and not integer division. Yeah, so I think we might have to. You don't want to use float, but is float okay? That's what I'm trying to think. Because it's only from 1 to 9, but or do we use a fraction class? I guess that's always the question. But you're only using, you realistically probably only doing 2 or 3 division. Well, I mean, you can't really do 3 division. You can, but it won't work. Even 2 division is a low. I don't know. How do you? Can you do 2 division? In 48 over 2 over 1, maybe. Over 1 doesn't really count, right? So that would be 24, and that's like 6 times 8, right? Yeah. All right, I'm just going to use float for a little bit. I think this is a little sketch, or more sketch than usual. Usually I like things to be more precise. But yeah, I'm just going to YOLO it. Okay. So maybe I don't need this extra step actually. Maybe I just, yeah, but okay. Since I already wrote it. How do you get? What is that? I'm trying to think about that editor tools thing to get like every possibility, but that's fine. Maybe I'll just do it this way. Okay. Right, let's just do this, just to make sure I'm not having off by once. Yeah, okay. So this is good. Good enough for me. By default, we return false, sure. Otherwise, okay. Also trying to be a little bit conscious of kind of space, but maybe that's fine. I don't know. Oh, and I was with a semicolon for some reason, but yeah, okay, fine. Nope. Yeah, I'm just being silly, but okay, fine. Okay. I find this kind of hard. How do I do a deep copy on this? Yeah, this is a mess, but okay. Yeah, let's just say this. I want to do it this way. Oh my. This is actually not I minus j, or it shouldn't be. Okay, well, okay. Oh, yeah, I should get some base cases. Oh man, how many times? I guess too many times. Oh, well, I guess it's harder to do recursion when you recurse on the wrong thing. Oh no, still. I don't know why I had to look at that, but that's odd, is it? Because it should get smaller over time. Or like, it should only recurse like 4 times, right? Unless I did something silly, which is also very possible, because oh, because oops. I thought I looked at it, but okay. Okay. This is true. That's good. I mean, it's good to at least have something be right. But now let's try the other 1, 2, 1, 2, 1. This will be, I guess, the limits of runtime. Oh, well, I guess minus divided by 0. Okay. Well, that's also a good catch. But okay, so 132 millisecond running probably exhaustively. Is this good enough to submit? I don't know, let's try some funky things. Maybe like the maybe I should get it. Well, at least I don't think I have to worry about running time. Is either this is wrong or not, so I'm just going to YOLO it a little bit. Oh no. Okay. Huh. So why this? Oh, the output thing is forced. Oh well. I think this is the part where possible fractions might come into play. Because I forgot to think about it a little bit. Okay. So the answer is that it thinks you can do it. Yeah, now I'm curious. What is the answer for 5, 4, 5, 7? So it is the division. Wait, well, because 5 divided by 5 is 1, then 7 minus 1 is 6, and then 6 times 4. So in theory, we should have a 147 somewhere. Oh, I'm dumb. Because now, okay. Because I only did from I. So this should also just be to get all the possible ones. So yeah, silly mistake. Okay. Well, I want to try the fourth case because that's the exhaustive case, just in case that I do way too much recursion. Okay, still one's in good time, so okay. Whoops. Oh no. Man. Huh. How do you do this one? Let's print out. So I should double check that this is doing fractions because it seems like Oregano, because there were a lot of zeros, so I think that's why is because there's no fractions. So because I'm doing this, how the hell did I do? Maybe something like that. Maybe just double a bit. Well, I mean that turned into true, but do we have enough precision? Okay, I'm a little lazy, so. But that was a very silly mistake in either case. Oh no. I think that's a fraction one. Because you have all these weirdness numbers. Okay, well. I mean, mostly, to be honest, I'm mostly just lazy because I think I was prepared for this being wrong, but still. But it's good to know that the algorithm works. So I was a little careless in this one, maybe because it's running late, but a lot of lines. But, yeah. So also we now know that it does about 9,000 comparisons, but is there one that's closer? Okay, fine. Oops. Okay, there we go. Okay. Okay. How do we want to do this? Maybe just a plus epsilon or something. But okay, fine. Yeah, this possibility I was, I guess, prepared for the. Okay, folding stuff is always not hard. Cool. Yeah, I mean, okay. So what were the 4 hours I did? Oh yeah, okay. So the first one was I just forgot that Jan I was on the wrong order. The second one, what was the second one? I forgot what the second one was. This is. Oh yeah. Well, the second one was I was doing integer division, and then the third one was because I have to fix that. I didn't use absolute value. Okay. Yeah. I think in terms of algorithms, it's just figuring a way to kind of exhaustively calculate every possibility. And it seems like there are about on the order of 9,000 possibilities, which is very easy. I mean, not easy to set up, but easy to run through, like just brute force, right? Yeah, and I think there are a lot of I mean, I think some of it was just me doing an educated guess on the wrong side. I think so. There's some carelessness here with the I and J needing to make sure that because I was just thinking about plus and minus, which are commutative. So, but I have to think about the multiplication actually even, but for the non-commutative, which is why I have to do from I to J. I mean, you could also have by you, I mean me. I could have also just actually just copy and paste this and then do J over Y. I think that should be okay. I think after that, well, there was a one silly mistake where this did the integer division, which was clearly called out even in the notes. So that was my silliness. And then the last one is just sometimes you take your risk because I think what was it? Oh, in this case, yeah, I mean, I just didn't contemplate the possibility of fractions around. I guess 1/3 is a little trickier because it's not because it's a repeating number in binary where 1/8, 1/4, and 1/2 are all have exact representation in binary. I think if I and some of that is just a little bit laziness on my part, to be honest. And maybe I should not be lazy on stream, but because you use a fraction class, and if there's no fraction class, you can implement a fraction class, then you get that precise there, and it's very obvious. But other than that, yeah, I mean, I think it's a fun problem, and it's a game that maybe many of us has played when we were younger, especially, or maybe just for nerds like me. But but in general, as a coding problem, I mean, I don't know. It's a 40 lines of code. It's brute force, recursive brute force. I mean, how much? As an interviewer, I would not give this problem because it's just a little too straightforward. If it's just brute force in a maybe slightly clever way, but that slightly clever way isn't even like I don't think I learned anything about how the person operates, so I would not ask this question. The coding is fine, but it's also like 40 lines of code. Maybe I can clean this up slightly, but probably not that much more. There's a lot of special casing in general, and I guess if you want to force the person to implement a fraction class, maybe that's interesting. But otherwise, yeah. But I mean, but that's as an interviewer. As a programmer who likes puzzles and solving it, I think this was fun. I mean, I think to be frank, I was probably have solved this like a long time ago. Not on Leetcode, obviously, and also not on anything other than just for fun. I think. I mean, I mean, like I said, it's a game that you play with your friends and family. Sometimes maybe on a long road trip, and the engineer in you is like, well, actually, I could probably just program this, and then you probably just done it to prove you can. But yeah, cool.